Now, if we observe our equation xl of t, we said that this is, we just derived the real and the imaginary parts, and from the above equation, if you see, we have this is e raised to power minus j 2 pi f naught t, right? F naught t. So we can write x of t to be the real part of xl of t e raised to the power j 2 pi f naught t. j 2 pi f naught t. You can observe it because we just need this one, right? We just need this one, x of t, and this is the real part. If you multiply this whole expression with the e raised to the power j 2 pi f naught t, so e minus j and plus j will cancel, you will be left with this one, and just the real part is only this. So your x of t is actually in terms of the low pass equivalent signal, which is the real of this signal, the real part. So we can write our x of t, or we can obtain our x of t from the low pass equivalent. Now we already have another equations, and from the above equations, which we write for the spectrum of our low pass equivalent signal. The spectrum is 2 times x plus f naught, and we said that this is equal to 2 times x of f plus f naught u of f plus f naught, right? We already derived it. So from this equation, we can write an expression for our x of f. We can write expression for our x of f along with another expression as well, because we said that okay, the x of f can be written as x positive of f and the conjugate of minus f, right? We said here minus f, the mirror image and the conjugate. So we can write our x of from these two. We can write our signal x of f in terms of xl of f. If you see, we can write our signal x of f. We can write x of f to be equal to x of f is actually obtained from this expression. So x of f is we have all the information in this positive, right? This one, x positive of f, and we said that the positive spectrum is represented as 2 times. Now you can see here from here 2 times this one. So we will have the positive spectrum, the shifted version of the positive spectrum is half, this 2 will come here, right? So x positive of f, and then you have to, this is an advanced version, so you need to multiply it with you need to delay this xl of f by f naught. So if you delay it by f naught, you will be left with let me write it and then I'll write this equation. Let me erase it from here first. I'll write this equation later on because I have to. Now see, if I delay xl of f by f naught, right? What would I get? I would get 2 times x positive of f, right? From here I can say that okay, my x positive of f is half xl of f minus f naught, right? We can rewrite this equation. Now, if we have this expression for x positive of f, and we already know from our previous knowledge, we already have this identity. Right? Now we can write our x of f. We can write our x of f in terms of XL, low pass equivalent signal. So this would be x positive of f, which is half XL f minus f naught, and the conjugate of the positive, and instead of f we have to minus f. So this would be equal to plus half XL minus f naught, and we should have a conjugate here. Because if you take the conjugate, you take the conjugate on both sides. Conjugate of this would be to the conjugate of this. So from here we can see. So the conjugate and the conjugate of minus f, right? You have minus f, so you just replace it with minus. So we can write our x of f in this form. We can write our x of f in terms of the spectrum of a low pass equivalent signal xl of f. Now we already derived expression for xl of t, and we said that our xl of t, the time domain signal, has a real component and imaginary component. So we say in phase component and the quadrature component, x q of t, right? Which we already saw in the above examples. So we have the xi of t and x q of t, and you can comparing it with the above equations, you can rewrite your xi of t, which is just the real part of the low pass equivalent signal. So this is x of t and cos of 2 pi f naught t plus the Hilbert transform, right? Hilbert transform sine of 2 pi f naught t, and our imaginary x q of t, which we derived earlier, is this is actually x q. This is x hat of t cos of 2 pi fct, cos of 2 pi f naught t, sorry, not fc, f naught t minus x of t sine of 2 pi f naught t. This we derived earlier, right? So with a little bit of little bit of mathematics, you can show that your x of t, this can be rewritten as in terms of x, the real and the imaginary component, and you can show that this is xi of t cos of 2 pi f naught t minus x q sine of 2 pi f naught t, and x hat, the Hilbert transform. If you solve these two equations for x of t, you would get this, and x, if you solve it for x bar of t, you can get x q of t cos of 2 pi f naught t plus x I of t sine of 2 pi f naught t. Now you can see we have the Hilbert transform and the original signal, both in terms of the I and q, the in phase and the quadrature component of the x of t. So we can rewrite here now. Once you know these in phase, the x of t and x hat of t, the low pass equivalent signal, you can always write it in the polar form. And I leave it to you people. Just go through the text and the notes and try to write it in the polar form, which is just simple. So in this lecture we conclude that we can write we can write our low pass equivalent signal, our low pass equivalent of the band pass signal in terms of the in phase and the quadrature. This is G. The in phase and the in phase component and the quadrature component of our x of t. So we can write the imaginary parts of xl of t. The imaginary part of xl of t are called the in phase component. The real part is called the in phase component, and the imaginary is called the quadrature component of x of t. So this is what we derived in this lecture.